Hey guys, welcome back. We are going to start our new playlist on um, DP, dynamic programming. It's a pretty nice topic, and lots of questions are asked in good companies, and you're gonna like it because if you know recursion, then it is a pretty easy topic because by changing s- simple lines, and you're gonna get the uh, DP, and the time complexity would be simpler. Okay, so given n items, each with a specific weight and value, knapsack means a bag, capacity of W means weight, task is to put the item in the knapsack such that the sum of the weight of the item is less or equal to W, and the sum of the values associated with be maximum. The values will be maximum. Maximize the like profit, or we can say value. Can either place an item entirely in the bag or leave it out entirely. Okay, can't put half of the portions or anything. Each item is available in single quantity. Got it? This is value, and this is what? Our weight. So value is 1, 2, 3. Weight is 4, 5, and 1. And then weight, that is capacity of the knapsack, is 4. Got it? Yeah. So first of all, we're gonna solve it by recursion plus memorization. Next, we're gonna solve it by top-down approach, that is by matrix. But if you know the recursion way, then the top changing to top down is pretty simple. Got it? And top down approach is um, mostly used. Okay, so we're gonna learn that also. Let us first of all understand the recursion way of doing this. Yeah, so if you see what the recursion wants, we want, let's make another function solve. We're gonna pass the value, weight, W, and N. N is not given, we're gonna make it because size is decreasing. N equals any val dot size, doesn't matter. Gonna pass int, obviously, solve value um int W, int N. N is the size. Okay, so first of all we'll write the base case. Got it? Base case is sorry, let's solve the base case. The base case would be like, what is the smallest valid possible? Like the smallest is n equals to 0. That means no items valid. N cannot be -1, obviously 0 if n 0. And also we can do like the capacity is 0, can't put anything. Okay, w is equal to 0. Two case, both for n0, no item, can't put anything and can't get any profit. So profit would be what? Profit, or we can say maximum value 0. For w0 also, if lots of items are there and you gonna put you can't put because the capacity is 0 of the, it can't be -1. No, valid, we want only the valid thing. Valid, uh smallest valid input. Got it? Smallest valid input gonna put, like smallest valid input is our, that is the item can be 0 or the capacity is 0. If any of them is 0, we gonna get profit as 0. No item is there, can't put anything in the bag, however however big the knapsack is. But if the knapsack capacity is 0 and you have lots of items, can't put it, so profit would be 0. This is the base case. Then we have to write the choice diagram. Okay, see, for example, item 1 has weight w1, value v1. Let's say, see, if weight is greater than w capacity, then obviously we can't put it in the bag. Else, if weight is less than or equal to w, two choices: you can put it, you can't put it. Got it? Can put it, or you also can't, you don't want to put it. Two choices. Or here is one choices. Let's write this. Pretty simple. Um so if um weight of, from the end only, yeah, n-1 is less than w or equal to w, we can either put it or not put it. Return maximum of, because we need the maximum profit. Let's write the put it. If you put it, yeah, if you want to put it, value would be added, value of n-1, yeah, plus the solve function with value no change, weight no change, w will be changed. W will be what? W will be w minus weight of n-1, and we have processed it, so let's proceed it for the previous ones. Got it? Yeah. And also, the, if you don't want to put it, like if you don't want to put it, then call the same function solve value weight w, because you haven't put it, and processed item is there. So let's move on to the previous items. You have processed the end item, so n-1 items you should proceed. Got it? Else, if weight of n minus 1 is greater than w, then return solve function value weight w n minus 1. That's all. This is a recursion that you want to write. Okay. But memorization also should be done. Yeah. I knew it, but TLE, you will show TLE. Runtime error. Because time complexity is too much. Got it? So how to solve this problem? We use DP, memorization. Memorization. Got it. So we need a matrix. Static. Static int t, let's say. Got it? This and this. What is the size? N plus 1, W plus 1. And then everything would be minus 1. Mm, 10 cube. So the size is Mila. Okay. And also we have to initialize. Um, let's initialize it also. How to? How to initialize it? How to initialize matrix? Yeah. Mem set. Name. Okay. Size of matrix. Okay. Or mem sec. Yeah. Mem set. Sorry. Mem set. Mem set. Name minus 1 and size of t. Everything initialized with minus 1. Now, okay. Now what do you do? If t of n w, okay, n and w Hmm. There you go. See, if the matrix has any value saved, that means it is not -1. It would return like then and there only. Should not proceed. Yeah. And otherwise, t of n of w is equal to this, and same here also. Let's try to submit it. What? So we have changed very simple thing, that we have made a loop for loop and initialized with -1. This change, and this is pretty nice. And there also power is something, it changes to, so you have to make like this, and code is here. Okay, we can also do some other way to solve this. That is our top down approach. Let's try to understand this. Let's understand the top down approach of this 0 1 knapsack problem. See, you are doing this thing, initialize base case. The base case is like this: n will be I, w will be j. Got it? Size will be like n plus 1 will be size, and j plus 1 will, sorry, w plus 1 will be, 1 will be size of I and j. Initialization. Base case will be changed into initialization. Okay, that is if, see, we need for loop. Yeah, for int I equal 0, I less than n plus 1. We have moved whole plus for int I j, sorry, j equals 0, j less than w plus 1, j plus plus, huh, if like 0, all the I 0, I 0 or J0. Huh? Any of them is 0. We gonna T of um what ij will be -1 or 0. Think of the base case. If I0, that means N0, W0, that means uh, 0, then we are just initializing with 0. Alright? What is the base case? You have to understand that. Now the choice diagram. See, if weight of n minus 1 less or equals to W, matlab, we have two choices. One is to add it, yeah. Another one is to not add it, yeah. Not add it and add it. If we add it, we have to add the value also and W minus something. So nice. T of I and J will be max of val of I minus 1 and is recursive into what? Into our um pretty nice iterative way. Let's try to understand what gonna do. See, T of obviously n, yeah, n minus 1, yeah, and W what? We have taken the size only of what is changing, that is n minus 1 and W minus what? Weight of I minus 1 and W2 J. Pretty okay, yeah. And if we are not willing to take it, then T of n minus 1 and J. Got it? And obviously Ij would be the iterative way we are taking now, not like the let's see. We have initialized, we have made choice diagram, and we need for too, because we have to just by the previous elements, by the initialization and all that, we're getting all the sub problems are uh, adding up to get the required problem. Okay, to get the required problem answer, we are all the things we are solving it to what our sub problems is adding up to solve the bigger problem, that is the problem required problem. Got it? Also here we need to for loop, yeah. Nice. Yeah, okay. Mm. And at last obviously we have to return T of n W. Yeah, I think we're gonna get it. What? Possibly your code does not work correctly for multiple test cases. What? What is happening? Your code output is um 0 maximum I. Um, I think it would be J, and let's see. Even more problems. Um, if J J minus J, yeah. Wait. Um, wait. I minus 1 is less or equals to what? W? I think W will be there. Hmm. Got it. I J na. And with J or what? J is our wait. Uh nah, it would be J only. I think so. Because J is changing, na? Or W. Hmm. Hmm. Oh. Oh. Mm. Hmm. Let's see the error. What is the error I've been getting? It. Okay, sorry. Ah, sorry. One. Nice. And it will be J only. What's W up to? W going now? Thanks.